Is PLC programming standardized across electrical engineering brands? Have you ever wondered how different brands of programmable logic controllers, or PLCs, communicate and work together? The answer lies in a framework that brings some consistency to the world of automation. Let's break it down. PLC programming is partially standardized through the International Electrotechnical Commission, standard known as EC 61131. This standard was first released in 1993 and has been updated since then. It defines common programming languages, models, and terminology for PLC software development. One of the key benefits of this standardization is that it allows PLC programs to be more portable and reusable across different hardware platforms. This means that engineers can write programs that work on various brands of PLCs, making life easier in industrial automation systems. The EC 61131 standard specifies 5 main programming languages. The first is ladder diagram, which is graphical and resembles relay logic schematics that electricians are familiar with. Next is function block diagram, another graphical language that combines data and functions. Then we have structured text, which is a textual language similar to Pascal programming. Instruction list is another textual language, but it is low-level and resembles assembler-like language. Finally, there is sequential function chart, which is a graphical way to organize program flow and transitions. These languages are widely supported across many PLC brands. This means that engineers can use a common set of languages regardless of the hardware manufacturer. However, it is important to note that complete standardization is not universal. Many individual PLC vendors implement proprietary extensions or unique programming environments. Some brands may restrict access to certain languages based on licensing. For instance, some platforms may only offer ladder logic by default and requiring additional licenses for other languages. Standardization also extends beyond just programming languages. It includes common terminology, programming models, and guidelines for lifecycle management and communication. This is especially helpful in advanced control functions like fuzzy logic. From the perspective of electrical engineering, this standardization simplifies design and troubleshooting. Using familiar programming constructs makes maintenance and upgrades easier. Engineers can learn a consistent set of languages and concepts that apply across different brands. However, it is essential for engineers to be aware of vendor-specific features and tools that can affect implementation details. In practical automation and control system design, adhering to EC 61131 standards improves project consistency and documentation. It also supports modular programming practices, which enhance code reuse and scalability. While the EC 61131 standard provides a solid foundation for PLC programming across electrical engineering brands, complete uniformity is limited by vendor-specific variations. Engineers benefit from using common languages but must adapt to brand-specific tools when developing or maintaining PLC programs.